Hey everybody, this is going to be the tutorial video for section 1.2, which is on the basic terms and postulates of geometry. So a lot of vocabulary, a lot of getting down the basic structures of the different objects that we're going to be using the whole year. So let's get started. Present my screen so you can see my document that you should have in front of you as well. Okay, so you should see my Word document at this point. All right, so again, the learning targets for this section are going to be able to understand the basic terms and postulates of geometry. There's not a lot of calculating in this section. It's a lot of learning notation, learning vocabulary, and getting used to the way that geometry works. It's a different way of thinking than algebra. It takes some getting used to. Once you're kind of in the geometry groove, you're on it for the rest of the year, but you got to get past the weird part of it first, which is the vocabulary and the notation. So let's just start out with some of the basic objects in geometry: points, lines, and planes. You've probably all seen points and lines before. You graph them in algebra, but we have specific definitions for them in geometry. So a point is just a location in space that has no thickness. Okay. And you've all seen a point, it's just like a dot, and the way we name it is with a capital letter. So here's a point A, a point B, there's a point C, and the way that you name the point in geometry is just by using the capital letter. Capital A, capital B, capital C would all be referring to those points I graphed above. A line, it's a straight path that extends in two opposite directions without end, so it goes on forever in both directions. Okay. And again, it has no thickness. There's an infinite number of points on a line because it goes forever in both directions. So for example, here's a line. You'll see that there's arrows on both ends, which means it's going on forever. I'm just going to put 2 points on the line, call it A and B. Okay. And I'm also going to put a little lowercase letter m. There's a couple different ways you can name a line. You can name it using 2 capital letters that are on the line, 2 points that are on the line, but then you have to put the line symbol above it, which is just literally a line with arrows on both ends. Okay. The order of the letters does not matter when you name a line because it's going on forever in both directions. There's no distinct starting point and there's no distinct ending point. So I could also name this line BA. Okay. Or if you see that lowercase letter, it's like a label for the line. It's not a point. It's just a lowercase letter that names the line. So I could call this line with a lowercase m. Notice I'm not putting the line symbol above it now because I'm not using 2 points to name it. Okay. So 2 capital letters with the line symbol above it that are on the line, or if there's another label with a lowercase letter, that works too. Just put the word line in front of it. Upping ourselves, so we did something in 1 dimension, which was a point, something in 2 dimensions, which is a line. Okay. Or I should say, point has 0 dimension, a line is 1 dimension, a plane is going to be 2-dimensional. So a plane, it's a 2D surface that extends without end, and again, it has no thickness. So now instead of moving in 1 direction, we're moving in 2 directions. So a plane looks something like this. What your mind has to imagine is that it's moving forever in both directions. Even though it just looks like a little 4-sided shape on my page, it's moving on forever to the left and right and forever forwards and backwards as well. Okay. And a plane contains infinitely many lines, just like a line contains infinitely many points. Okay. The way I name a plane, I'm going to put some points on here. Say this is A, B, C, and I'm going to put a little capital cursive P in the bottom here as well. You can name a plane by using any 3 points that don't lie on the same line, and the letter order doesn't matter. So I could name that plane ABC. Those 3 points are on the plane. Could call it BAC, CAB, CBA. You just have to make sure that the 3 points do not lie on the same line. Okay. So 3 points, not all on the same line. Because otherwise you would just be naming a line, not a plane. The other way you can name the plane is by using the label, just like for the lines, how we had a lowercase letter label, we have a capital uppercase label for a plane, but it's not a point on the plane, it's a label. So if I'm going to name it with the label, I'm going to call it plane, put the word, and then I put the capital letter P, because that's what I named the plane. Okay. Some vocabulary. When we talk about things being collinear, this just means points that are on the same line. Okay. So for example, here's a line. Here's point A, point B, point C. I would say that points A, B, and C are collinear in that case because all three of those points lie on the same line. Likewise, coplanar, this means points or lines. Uh-oh, my pen's not writing. That's not good. Technical difficulties. Give me one sec. There we go. We're back. Oh, looks like it didn't save it, though, so I'm going to have to write that part again. Okay, so collinear was points that lie on the same line. Lots of technical difficulties with this writing. Okay, so for example, there's our line, point A, point B, point C are collinear. They all lie on the same line. Coplanar, we are talking about points, or in this case, it could also be lines that lie in the same plane. So for example, here's my plane. Let's say here's point A, point B, and point C. I'll give it a point D also. Okay. So A, B, and C and D would all be coplanar. They all lie on the same plane. Okay. And line CD also lies in that plane. Okay. So that would be coplanar as well. Okay, so let's say they give you a diagram. Now that you have some basic ideas as to how to name these objects and label them, let's see if we can answer some of these questions. First question, so we're looking at this diagram over here on the right. What are two other ways that you could name line QT? So here's line QT, and I'll explain what the little dashed part means in a little bit. But there is the line that we're interested in. Okay, and again, this part is dashed. Label that in a different color. Dash, dash, dashing through the graph. Okay. Two other ways to name line QT. Remember, you just have to pick points that are on the line. So I noticed that I could name this TQ if I switch the order. There's nothing wrong with switching the order of the points on a line. Put the line symbol above it. Point N is also on that line, so I could call this NQ. I could call it NT, TN, doesn't matter. Just got to pick points that are on the line. Okay. I also noticed that there's a little cursive lowercase l, so I could also name this line line L. It's not a point, but it's a label for the line. Two other ways to name plane P. In order to name a plane, you need to pick 3 points that don't all lie on the same line. So I noticed that point R, point S, and point V are 3 points that are on the plane, but they don't all lie on the same line. Okay. 2 of them do, but that's okay. It has to be all 3 as a whole do not lie on the same line. So I could name this RSV, could switch the order around. I could call it VRS. Okay. What are the names of 3 collinear points? Remember, that vocab word means they lie on the same line. I noticed that R, Q, and S all lie on the same line, so that would work. I could also use, let's do a different color. T, Q, and N all lie on the same line. So, or T, Q, N. The names of 4 coplanar points. Remember, that means that you have points that lie on the same plane. Okay, so if I look for some points right now that all lie in the same plane, V, R, Q, and S all lie in that plane. So V, R, Q, and S. What are 2 points that are not coplanar with R, S, and V? This is where the dotted part of that line comes into play. So you have to think of this as a line that's cutting through your paper or cutting through your plane. Okay, so pretend the piece of paper is your plane. So you can see this. Here's my piece of paper. Up at the top of my pen is point T, and the part that I write with, the little tip at the bottom, is going to be point N. And what's happening is this line is basically cutting through the paper. So I'm just going to poke a hole through my paper. See if I can hold this up to the camera. So you can see now the top part of my pen is not on the plane, and the bottom part of my pen is also not on the plane. So the pen cap would be point T, and the part that I write with on the bottom would be point N. So what's happening here is the point at the top and the point at the bottom are no longer on the plane. So when it asks you what are 2 points that are not coplanar with R, S, and V, R, S, and V are on my paper. I just drew them in. But if you poke the hole through, that's what the little dashed line means. T is now above the plane, and N is now below the plane. So T and N are not coplanar. It just means you have a line that's almost poking a hole through your plane. Okay. So anything above on that line is not on the plane. Anything below is not on the plane. So we'll put T and N. Okay. Another interesting question to think about is, are points Q and V collinear? So if you look at your plane, here was V, here was Q. Even though you don't see a line, think about what can you always draw between 2 points. Any 2 points you have, you can always draw a line between them. So that's an interesting little takeaway here is sometimes even if we have 2 points, you're always going to be able to draw a line between them. So the answer to this question is yes. Hey, through any 2 points, not 3, but 2, through any 2 points, you can always draw a line, which means any 2 points are always going to be collinear. Hey. And this is just a little joke. It's Snakes on a Plane, which is actually a movie, but this is the geometry joke. You got some snakes lying on a 2-dimensional surface. Ha ha ha. All right, moving on. Some more vocab. We talked about lines and points and planes. Sometimes we want to just talk about a portion of a line, which is either called a ray or a segment. So a segment, it's part of a line that consists of 2 endpoints and all of the points in between them. So now we're not interested in the line going on forever in both directions. We have a distinct starting point and we have a distinct stopping point. So in a diagram, your segment would start at one point and it would end at another point. It would not go forever in both directions. You would have endpoints. So the way we name it, the order still doesn't matter because I don't know which one's the starting point and which one's the ending point. I could either name it segment AB, and I just put a bar above it, so no arrows, or I could call it BA. Again, no arrows because it's not a line anymore. It's not going on forever in both directions. Array, it's kind of like a combination of a line and a segment. It has a distinct starting point, but it doesn't have a distinct ending point. It's going to go on forever in one direction. Okay? So it's part of a line. It consists of not 2 endpoints, but 1 endpoint, and all of the points on one side of that endpoint. So for example, in this first one I'm going to draw, let's say that this is AB. So in the first diagram that I'm drawing, it starts at point A and then it goes forever in the direction of point B. So the way I would name the one in green, actually, let me use different letters for the bottom one so it doesn't get confusing. let's use C and D for this one. Okay. So for the top one, I would have to name the ray AB. And the first letter I use is always the one that has the endpoint. The second letter I list is the one in which it's going in that direction. And I put a one-sided arrow that points to the right to denote a ray. Okay. So only one arrow, not two, and it always points to the right. Okay. So not BA, because it doesn't start at point B, it starts at point A. Okay. So this is a big no-no. It is not BA. And then the one on the bottom starts at point C and it goes forever in the direction of point D. Put my ray symbol. It is not ray DC. No, because it doesn't start at point D, it starts at point C. Okay. So basically the letter order for a segment or a line can be whatever you want. Doesn't matter which order you list the letters in, but for a ray, the order matters. You have to put the endpoint first, and then the second letter you list is the direction it's going in. Opposite rays. Okay. What are opposite rays? You need two of them. So opposite rays are two rays. They share the same endpoint, so they have to start at the same point. And when you put them together, they form a line. Okay. So those are the two conditions you need to have. They need to, one, share an endpoint, and they need to, two, form a line. If either one of those is missing, you don't have opposite rays. So let me draw you a picture so you can see what those would look like. So on a diagram, if I say same endpoint, it means they start at the same place. So let's say this is A, but then one of them is going to have to go to the right. So let's say that's ray AB. But in order to form a line, the other one's going to have to go to the left. So let's say there's C. So one of my rays would be AB, and the other one would be AC. Okay. In both of those cases, they start at the same spot. Both of them start at point A, but then this ray goes forever to the right in green. That's ray AB. And this ray, let's do it in pink, goes forever to the left. That's ray AC. Okay. Make that a little bit darker, just so we can see it. Okay. Those would be considered opposite rays, and you can tell they start at the same exact endpoint. They both start at A, and they form a line. Opposite rays. And so example 2, here's a diagram. Use the figure to the right to answer the questions below. So we've got a line that has 3 points on it. First thing they want to know, what are the names of the segments in the figure to the right? So remember, segments means distinct starting point, distinct stopping point. So I see a segment from D to E. So I'll call that one DE. Put the bar above it. I see another one that starts at E, goes to F. So from E to F, I've got another one, EF. And then we've also got the big one that starts at D and goes all the way to F from here to here. So DF would be another one. And remember, the letter order doesn't matter. You could switch it around for a segment. Okay. What are the names of the rays in the figure? Well, if I want to name the rays, let's see what we got. Distinct starting point. So which rays would start at D? Well, there's only one ray. Let's see. From D in the direction of E or F, it doesn't matter which point I use because it's going to be the same ray. So I could call it DE or I could call it DF. That's one ray. Another one, let's see which rays start at E. Here's E. EF would be one ray in red. But I could also make one that starts at E and goes in the direction of D. That would be a different ray. That would be ray ED. Which, remember, it's not the same as ray DE. ED and DE are two different rays. The starting point matters for a ray. And then last but not least, what if we started at point F? If I start at point F, there's only one ray I can make. And it doesn't matter which letter I list second. I could call it ray FE or FD. So I'll call it FD in this case. Okay. Which of the rays in part B are considered opposite rays? Well, remember, that means they need to have the same endpoint and they need to form a line. The only point that rays would share in common here would be point E. So I definitely know it's going to have to start with E. One of them goes in the direction of F, so that would be ray EF, and the other one goes in the direction of D. So together, those form a straight line, and they start at the exact same endpoint. That's the other condition. So then critical thinking, it says in the figure to the right, EF and FE form a line, right? Let's draw it. I'm going to erase this. Save this first. So they're saying EF, so that'd be, oh, still saving. Sorry about the technical delay. There we go. So EF starts at E, goes in the direction of F. FE starts at F, goes in the direction of E. Definitely makes a straight line, but they're not opposite rays. So see if you can pause me for a minute and think about why would those not be opposite rays, even if they form a line? What condition is not met? Once you think you have it, press play again and we'll discuss. Okay, so the reason that they're not opposite rays is because they don't share the same endpoint. Ray EF starts at point E, but ray FE starts at point F. So they are not opposite rays because they don't share the same endpoint. Okay. You got to have both conditions. They form a straight line and they start at the same endpoint. Next vocabulary word is what's called a postulate or an axiom. We're going to have plenty of these this year. This is just an accepted statement of fact. For example, Chicago is in Illinois. I mean, that's pretty much an established fact, right? Nobody can argue Chicago's in Illinois. Okay. Something that's more of an opinion, though, like dogs are better than cats. I mean, I think so. I love dogs. I like cats too. But that can't be an accepted statement of fact because there's going to be people that say cats are better than dogs. So that would not be a postulate. Okay. This has to be something that's factual no matter what. And in geometry, we have plenty of them. So I'll give you a few of them today. Okay. First one helps if you draw it. It says draw 2 points. Okay. Here's 2 points. How many lines can you draw through those 2 points? If you take your pencil or your pen, there's only one line you can draw. Okay. Red and blue, go Cubs. Okay. So this creates a postulate. There's no arguing. There's no more than one line you can draw through those 2 points. Any 2 points determine exactly one line. Okay. Accepted statement of fact. How about 3 non-collinear points? If I have point 1, point 2, and a third one that's not on the same line, those are always going to determine exactly one plane. There's only one plane that I can draw surrounding those points. So any 3 non-collinear is the key. Any 3 non-collinear points are going to determine exactly one plane. The reason they can't be collinear points is because otherwise they would just make a line. They wouldn't make a plane. A, B, C. That's not a plane. That's just a line. You need to make sure at least one of those points is not on the same line. Okay. So this would form a line. Form only a line. Okay, let's talk about intersections. Let's draw 2 lines that intersect, means they cross. And from algebra, this one you're probably familiar with. Uh-oh, come on. If I draw 2 lines that intersect, line 1, line 2, how many times do they cross or intersect? They only cross at one point. I'm going to draw it in red. There's the intersection point. So this is a postulate. If two lines intersect, if they do in fact cross, then they intersect at exactly, to clarify, 1 point. Not 2, not 3, exactly 1 point. How about planes? If I have two planes, think about two pieces of paper that cross. If two planes intersect, they're always going to intersect in exactly one line. So for example, in the picture I have here, you got the purple plane and you got the green plane. Both of them overlap in ST. It might look like a segment to you in the picture, but you have to remember planes extend infinitely in both directions. So this plane's going to continue to move on forever this way and forever this way. You just don't see it in the picture. So for that reason, the intersection is not a segment, it's a line. So this is another postulate. If two planes intersect, then they intersect in exactly one line. Make sure you have line there, not segment. Don't let the picture throw you off. There's the intersection. Classic type of example to do is use a cube or a box to answer some questions. The box has 6 different planes, 2 on the top and bottom, 2 on the left and right, and then 2 in the front and back. So naming, let's say we want to name that front plane in 3 different ways. So here's the plane they're talking about, the one in the front. If I want to name that plane, I see different letters that are on it. I can use 3 of them. Remember, 3 capital letters that don't all lie on the same line. So why don't I name it EFA? Those letters show up on the plane. Or I could use EBA. B is also on that plane. Or I could call it BAE. Any of those work. And there's more options too. What is the intersection? So now we're looking at where they meet up. What is the intersection of plane HEF and HEA? So let's label what that would be. HEF would be the one on the top. So maybe I'll actually highlight it. So here's HEF. And then HEA is going to be the one on the left-hand side. So if you look at where those overlap, they intersect in that top little segment right here. But remember, it's not just a segment. Planes go forever in both directions. So the intersection is actually going to be that entire line, HE. Okay. So you're just looking for the place where they overlap. Intersection just means where's the overlap? Let's do another one. Where is the intersection of plane ABF? So that's the one in the front. And CGF. CGF is the one on the right. Okay. So here's my front plane. That's ABF. And CGF. CGF would be this plane. You can even see it kind of changed colors there. They're overlapping in that front right corner. Okay, that line right there is shared between both planes. So this intersection would be line BF, or you could call it FB. Next question is backwards. They want you to find 2 planes that intersect in line GC. So I'm going to label, here's GC. You got to find 2 planes that intersect that line. Okay, so think about 2 planes that maybe have that as a side length. See if you can figure that one out. Pause me and then we'll do it. So one plane I definitely see is this one on the right. So we'll just call that GFC. That definitely has GC as a line. And then the one in the back also has GC as a line. I'm going to outline it so you can see it. This plane, the one that's sitting in the back facing up and down. Okay. So that would be plane HDC. Other ways you could name it too. But that's the only case you're going to get where you get some overlap on that segment right here. Or that line, GC. Okay. Last question wants to know, name a pair of parallel planes. Parallel in math, if you remember from last year, means don't intersect. Remember graphing parallel lines on the coordinate plane? This means they don't intersect, they don't cross. So think about what would be cases where you wouldn't get any segment or line overlap for these planes. I'll give you one case, would be the plane on the top and the plane on the bottom. They're going to move forever in their respective directions, but they're never going to cross. Okay? There's going to be no intersection. So for example, we could have plane HEF and plane DAB. Okay, that would be the front and the back plane. You could also have the one on the left and right, HEA, GFB. The left and right ones are not going to meet up, or you could do the one in the front and the one in the back. So HDC and EAB. Okay. Front, back. Oh, I labeled it wrong. Sorry. This should be top, bottom. HEF and DAB is top, bottom. Okay. So top, bottom, left, right, or front, back. Any of those pairs are not going to meet up. Okay. One warning, word of caution. Sometimes people like to name planes with 4 points when they show up in this cube type diagram. That's okay. You can use 4 points, but you need to make sure that you're listing them in a consecutive order. So for example, if I wanted to label the plane GFBC, so GFBC, you need to make sure that your points go around either clockwise or counterclockwise in order. So if you named it GFBC, that's fine, or GCBF. But if you start jumping corners like G to B to C to F, that's not okay. You can't name a plane when you cross corners. Go clockwise, go counterclockwise in order if you're going to use 4 points. Or just use 3, and then the order doesn't matter at all. Just one of those little sneaky things in geometry that they're picky about. Okay. Last set of examples for this section is having you shade some planes. So it says use the figures below to answer these questions. In part A, what plane contains the points N, P, and Q? So I'm just going to label those with red dots. N, P, and Q. I'm going to shade the plane. Okay. And you'll see in some of these examples, it might be one of the 6 planes surrounding the shape, or it might be one that we actually have to sketch in that's new. Okay. In this one, I can see all of those points lie in the bottom plane. So the only one that's missing is R. Okay. So this plane would be the one on the bottom. Okay. R would also be a part of that plane. In B, what plane contains the points J, M, and Q? Let's do blue this time. Here's J, here's M. And this is what I'm talking about when I say it might not be one of the 6 faces that you see in the picture. J and M are on the top plane, and Q is on the bottom plane. So how the heck do you make a plane that goes from the top to the bottom? You got to sketch it in. It's like a slide. You're starting at the top and you're going to the bottom. If M would nicely connect to Q, think about what point J would nicely connect to. It has to be kind of going in the same direction. J is going to go all the way down to point P. So in green, here's my plane. It's like a slide that goes from the top left corner to the bottom right corner. It's the only way you can get from the top to the bottom. Next one. What plane contains the points L, M, and N? So let's label the points first. L and M are on the top, and N is on the bottom. So this is another one you're going to have to sketch in. The only way to get from that top all the way down to the bottom would be if M connected very nicely to N, but then L would have to connect very nicely over here to P. And then I'll just shade in my plane. Let's shade it in black this time. Okay. So there would be my plane. It's like a slide that comes from the top at me, coming down to the bottom. And then last but not least, what is the name of a line that is coplanar, means in the same plane, with JK? So here's JK in blue. And KL. Here's KL. Okay, so you got to find another line that lies in that plane. Okay. First thing to notice, both of those lines are in the top plane. So you've got to find another line that's in the top plane. I'm going to highlight the top plane in yellow. Both those lines are in the top plane. So you got two options. You could either use line JM, make sure you put your line symbol above it, or you could use line ML. That's also in the top plane. Either of those lines would be coplanar with JK and KL. So a lot of vocabulary, a lot of little things you have to be careful with, like, do I use arrows? Do I not use arrows? Does the letter order matter? Does it not matter? These are things that'll get easier, but kind of going back to this video and looking back at some of these little topics is going to be helpful throughout the first chapter. And that will do it for the first section. Have a good rest of the day.